Hello, everyone. I came from Russia to tell you about WebGL. WebGL in two-dimensional art. I made my own illustration for the slides. It's a smart foxy that illustrates my attitude to strong technologies, to less involve in WebGL like a smart foxy. Fox, it's an animal from my country that looks like a monkey in your country. It's too smart. And let's involve in WebGL. So a couple of words about myself. My name is Alexander. I'm a front-end developer in a bank. And also I made meetups in my city, St. Petersburg in Russia. And also I'm a really big fan of game development, and I make games for web. Maybe in this audience, anybody make games for web? Not? Nobody? Okay. So, and also, I also recommend you to, if you want to become a speaker in Russia, to become a speaker in Russian conference, you can go to this list. I maintain this, and this is a list of Russian conferences. Some of them can accept your talks in English. In case if you have a really good idea, you can go to Russia like me go to Nepal. And I told about I make games for the bank. In many countries, banks is truly official organizers, truly official companies. But our bank is not this. Our bank is full online bank without offices. And all our marketing goes through the internet. And sometimes we make games and make collaborations with bloggers to involve new customers and clients. It's why we need WebGL in our bank sometimes. So many people scared about WebGL because it looks like a magic. It looks not predictable. It looks like absolutely different technology in our web. But basically, WebGL is just something to draw triangles. It's a basic concept of WebGL. To draw two-dimensional, to draw three-dimensional, WebGL just draw triangles. It's a basic idea, it's a main feature of WebGL. And almost all methods that you have for WebGL do this stuff. Just draw the triangles. It's simple, why not? And what about WebGL in history? The history of WebGL is 9 years, but in difference with WebAssembly, it's already in stagnation because we have really good, interesting technology, WebGPU, but it's not on stage now, and we have only version 2 and version 1. And looks like WebGL is not so far away from any stone in difference with WebAssembly, because WebAssembly has a lot of money to maintain, has a lot of maintainers, and it has big growth for the last 9 years instead of WebGL. But WebGL is too standard and not so mutate. Exactly, I want to tell you about API. API looks not so webby. It's not looks like an API from web because some of these functions can pass 7 arguments to work. It's hard. It's really hard. And some of these functions has really weird names. But feel free, all of these functions is just set state methods, because in WebGL we have global state, and this global state renders on our video adapter. And all functions that you need, it's modification of this state. You can set the state, but you cannot get this. You cannot check it. You can debug it without going to video adapter. It's make debugging of WebGL hard, but it's also state methods. To summarize all information about WebGL that you should know to this moment, we have global state. We can set it, we cannot get it. We have a low amount of good examples to describe how actually work with WebGL, and in this case, it's hard to enter, really hard. Exactly the absolutely obvious question, how to make a new JavaScript library that makes JavaScript simpler. For example, getting a canvas API to draw something, to draw primitives, to draw rectangles, lines, and so on. But this library exactly exists, but nobody uses because WebGL with canvas API not became faster. It means that WebGL not makes all of stuff faster that exactly we want to see, but we can work with it because WebGL is different, totally different, and it means that we need to think different. It means looks like a theory about nobody should understand WebGL except free experts, free professionals that grab free vacancies all on the marketplace. And but I tried to make it, and I made first demo to understand WebGL. So let me show it. So I just make a canvas with rectangles. It's like a chessboard, and I made it with WebGL effects. You know, I draw rectangles on a canvas, use it as a texture in WebGL because the only thing that can workable in WebGL is a texture. You cannot draw rectangles, you cannot draw lines, you cannot draw primitives. You need to think in textures. So it's my first demo to understand how it works. It bases on the WebGL fundamentals simple example to draw the image. Because you can go to webglfundamentals.org to find a lot of simple examples to draw something with WebGL. It has a lot of code, but you can just copy it and modify it. To understand technology better way, it's just copy and modify it. And I made so. So my algorithm was about getting this example, replace image with canvas, draw something on canvas, and use it as an image, like a texture. It's possible, it works, and it's a simpler way. So. We can learn another really important thing, that WebGL is not draws anything anymore. It's just modification of state, because all drawing stuff goes with shaders. Shaders is another browser language that can work in browser named GLSL, and it's a GLSL language script. It compiles on a video adapter, and it works for every pixel on the screen. Looks like it's a program for every pixel. This program makes very simple stuff, just passing the pixel in the video adapter, passing the pixel of our picture. To draw one picture, we need shader. To draw anything in WebGL, we need shader. We can copy this from webglfundamentals.org and use it. And exactly to make a game, we need more than one image to combine it and make a game from the different images, and it will work. So to use different images, we need shader too. And in shader, we can summarize images. In JavaScript, we cannot, but in GLSL, in strict language that looks like a pure C, with the types, with compilation and so on, we can summarize images. Looks interesting, yes? And not only summarize, we can use different mathematical operations to it to grab the result. At the right side, you can see the result of different operations, how different operators works with it. And to see them, you can see okay, I can make effects for my game very cheaper, just using absolutely simple mathematical operators. Why not? And the main idea of shaders, I want to say it's about program for each pixel on the screen. It's like just imagine big stadium with a lot of foxes, and all foxes know in which time he needs to show the sheet of paper with a needable color. And we make programs like these foxes. With a lot of foxes to make big picture, but the only fox have the one sheet of paper with current color. It's all. Absolutely simple concept. And exactly what to do with shaders, what we can do with that. And I want to show you a game that make with shaders. So a game is absolutely interesting example because it has a very simple canvas render. Canvas render just for primitives, but shaders make these games absolutely perfect. And this game was a winner is Game Jam. Oh, I'm loose. So games make me think about I need shaders and Canvas to work together, to make Canvas make stuff that works perfectly with Canvas and make shaders for effects. It's all that you need to know. And something about script text, because in WebGL-fundamentals.org you can find a lot of examples with script text shaders. This is the code of shaders that passed in script text in HTML. But in our year, in this year, in current year, it's already not modern. Don't use that approach. Use Webpack. Webpack is pretty simpler because you can find row loader to load everything as a string because you need to pass your shader code as a string to the WebGL to compile it. And your code became better. It's a JavaScript like your models, like common JS models you found you used before, and it works. It just works, and your code looks better than with script text. And exactly to compile shaders, feel free to go to WebGL-fundamentals.org and use WebGL utils library. Everybody in WebGL works using WebGL utils to do some common stuff. It's to do some usual stuff. And this is the links for shaders you can find. This is a book of shaders and shader toys. This is big galleries of shader examples. Many of people, oh, what to do with my video? It works. And many of people looks like they absolutely don't have free time for them because they have absolutely interesting demos and just go to the first links to see, and Jelly Box too. And the book of shaders is a book to learn how the shaders works because if you need to make effects, you need to learn how to work with programs for each pixel. So it's my demo about shaders. I made this game with different canvases. By the link you can find, you can navigate and play. It's just different layers, and all of them works with shaders because starts on the background is animated by shaders too. Almost all of them animated by shaders and makes effects using this. It's just canvas that draws rectangles, stars, and rectangles, but it works as a game with a complete render. And the simplest way to involve in WebGL and using React. Because React makes a really good shield to you, really good helmet, good exoskeleton to you to go through the strong WebGL world. Because it makes abstractions that you really need to use to think about business logic, not about WebGL redrawings. And let's go to Google and search something. In case if you want to search something in Google, you found that better to use React Pixie wrappers because you need to use Pixie library, not React WebGL libraries, because React WebGL libraries is for three-dimensional. But you need to do two-dimensional, better to use Pixie. Why Pixie.js? Pixie.js is the most famous render for two-dimensional art, games, and so on. It's already standard in game development for web. It's a render for WebGL that can use Canvas and so on, and it has a good abstraction from WebGL. And in case of you using with React, we have good abstractions. We have good abstractions of WebGL. And I made this demo. This is a simple demo of colliding starts with a player, and this demo was made for 40 minutes. I just lean in train to another city of Russia, and I want to sleep, but I made this demo for 40 minutes only. It's pretty simple, and simplest part of it is render. It's all render of this game. It's just 6 strings of JS code, JS6 code, well-known JS6 code from React, and you can use it to you can use game. You can make game like interface, because you can make a game like your React application with common things, with props, with set state, with so on. And looks like everybody can read this code and can understand what actually happens in this code. And we can grab a full abstraction from WebGL API. It's pretty simple to us to not think about redrawing and so on, about matrices and so on, but we need some time, but sometimes we can need shaders. This game was without shaders. And exactly, all good ideas should be tested in production. Because in case of you have a good idea, you should test it in production. You should deploy it for many users, because nobody can trust your idea without production usage. And I have production story. So it's a game that I made for bank to share promo codes to one winter festival. Yeah, in Russia we have winter festivals, and I can start it from start. So as you see, we have daylight time. After some time, it became evening. We have a lot of persons. We have a lot of items. We have movement. It's a runner. So I give very fast demo. At least one day I spent for this demo, just not on this game, just for demo with boxes and so on, to show designers how it should be. Because I need to maintain with designers this game, because designers should should add some new content, and we have a really good feedback loop. Except I use plain WebGL or plain Pixie.js. And I grab adaptive images for different devices, and Retina displays are workable too. Exactly, I have a couple of minuses, but I'll go next and I describe it. So game became interface with state, with props, with so on, with all stuff that we already common with React. And it became our development really simpler for developers that are not common in game development, that are not involved in WebGL. It's just React application for him. It's simple. And something about Retina displays, about resolution, it goes from the box of Pixie.js. It's just config of Pixie.js application, and you can pass device pixel ratio variable to react on the Retina displays. And about adaptive, it's the most complicated question, because for adaptive in React application, usually we are using CSS at the below. But in JavaScript and Pixie.js and WebGL, we cannot use CSS anymore. We can use only JavaScript, and at the top, you can see code that actually works for the Pixie.js application. I need to make some helpers to make adaptive from JavaScript, from the algorithms, not from CSS, unfortunately. This looks like this code do the same work, but I cannot use CSS, unfortunately, only JavaScript. And about SVG, we can use SVG in Pixie.js. It's really good news, because in case of we want to use Retina displays, we need SVG, but we need concrete sizes of it. And what about runners? It's good for static games like chess, but what about runners? Because runners, it's a 60 FPS story. And in case of you can make set state, you can make all frames from state. You want to make all frames from state, but it's wrong way. It's absolute wrong way, because of because React is not invented to pass set state every frame. And good solution to use viewports. Viewports, it's something like iframes. You need to grab it in a custom component. React Pixie Fiber has this approach. And you can use it as in your JSX in your JSX3 as just a plain component, and all children is scrolled as an iframe. It looks as iframes. For my game, I need different viewports to make it workable. And as I think before, its concept looks like iframes, but with opacity. Iframes with opacity. Looks good. And how it looks in my game. In my game, we have iframes viewports for any movement items, and for player 2 to make vertical movement. And let's see the game with another eyes, and you can see different layers that have different speed. And I need viewports to deal with it, you know. So, as a summary to it, we have fast prototyping. Developer experience is absolutely good. We have a well-known stack, but I have too much risky experiments to make it in production, because exactly first version of my game was with set state in every frame. But I remade it with viewports in a couple of days. It was really risky before production. Really risky. Avoid set state, please. So, what about shaders? In case of I mentioned before, you can use shaders with React and Pixie, and how to use it. So I made this demo. After I made this game, it's just beer, Russian beer, and the car that burned. It's from a Russian joke. Yeah, maybe after. So we need to make a shader component that wrapped Pixie filter. And we need shaders and we need uniforms that goes as variables in our shader. And we can use it in just plain container. And after some manipulations, we can use our component to wrap any children to make effects on these children. And this works like in car before. So right now I'm making a game for conferences in coding, about coding, and I stylize it in a Vim editor. And I want to make shader effects on the text, and this works as a filter. I just made effects on the letters, but not for background. Only children's effects using these shader effects. It works absolutely perfectly. It's better than you can try to use WebGL, plain WebGL. So, but what about shaders from Google? Because you need to Google new shaders, because nobody should make new shaders for your game, because any shaders already wrote. Any shaders already complete. But you can find that version of the shaders is completely different with WebGL using in your machine, in your browser. And looks like it's GLSL 3.0 support you need to check. But unfortunately, it's not so have a good support in web. And in case of you have Chrome or Firefox, it's okay, but for all browsers, not. You need to downgrade to first version of it that uses WebGL first. And unfortunately, GLSL 3.0 in Pixie.js is broken. It have an approach to work around, but it totally is broken. And the better solution to detect it is to pass, try to compile and check the error. Worst solution, why not? But unfortunately, it's one solution. And one pass we have, one way we have, it's using downgrade our shaders from internet from third version to first version. If you want to use some effects like bloom and so on and so on. And what about key takeaways that you want to learn from this talk? So, is it WebGL really draws faster? I want to answer you sometimes, because in case of we can try to use all stuff that we can grab from Canvas API, our primitives, text, and so on, is not so fast. But we can start working with it in case of we start thinking as in the textures, not in primitives, think in textures, because everything except textures in WebGL works not so fast. because you need to draw its canvas beforehand. And what about effects? Unfortunately, GLSL is a mandatory skill for it, because it looks like you cannot avoid learning of WebGL API, but you need to learn how to work with GLSL, how to make your own shaders. And you can use Sandbox that you found in links slides. And you can try yourself, and it was really interesting. Sometimes I spent a lot of hours to make my own shaders. This is the link section. You can find the book of shaders to learn how the shaders actually works from the start, from the scratch. Shader tool, JSL box, where you can try your power, and link to the demos with repositories to show my code to you, to share my code. So it's a link to presentation, my social networks, and it's all.